the A/B testing of a flight information page on the website of an airport is done. And so they decided that the less time a visitor spends to find the flight of his or her interest on this page, the better. So they measured time in seconds for every visitor, how many seconds the visitor looked at this page. And so the results are as follows. So, and the two interfaces were compared, so interface A and interface B, as usually in A/B testing. And so for interface A, times in seconds were 30, 28, 46, 42, 35, 33, 44, 31, 43, and 38. And for the variant B, they were 26, 38, 39, 28, 30, 27, 32, and 35. So these are the times. So how long they looked for the flight of interest on this page. And so the question is, can we say that interface B is better? So can we say that B is better? So, okay. If we use the Mann-Whitney-Wilcoxon test, the first step is to formulate the hypothesis we are going to test. So there is a theta. Theta is so how much the elements of the second sample are on average greater than the elements of the first one. So this is difference in means. And so positive theta means that elements of the second sample are on average greater than the elements of the first one. And negative theta means that elements of the first sample are on average greater than the elements of the second one. So the elements of the second are on average less than the elements of the first. So they say that they suppose that B is better. So what does it mean? It means B is better than those who looked at the B version spend less time looking for their flight. So B is better means that visitors spend less time to find their flight. And so that means that B is better means that elements of the second sample are on average less than the elements of the first one. So that is why the hypothesis they ask us to test is that theta is less than 0. That theta is negative. As in previous example, this is a composite hypothesis. So that is why we also can adopt it as an alternative one. And the null hypothesis is always the same in this type of problems, so theta equal to 0. So physical meaning of the null hypothesis is that there is no significant difference between A and B. They are the same, of the same, how to say, efficiency. And the physical meaning of the alternative one is that B is better than A. So visitors who used the B version found their flights faster. So then we are to calculate the test statistic. So the first step is to rank the observations. Let's do this. So we are to start with the least one. The least one is this, 26, and so its rank is 1. Then we have 27, and its rank is 2. Then the next one is 28, but we see that 28 is present twice here, this one and this one. So what can we do in such a situation when we have two observations of the same value, how we are to rank them? So the ranking in this case is done as follows. We give them average rank. So we say if they were different, so they are equal, these two observations, but if they were different, their places, their ranks would be 3 and 4. So they share the third and the fourth places in these rankings. In this ranking, average is between 3 and 4 is 3.5, 3.5, and so that is why we give them rank 3.5 to both observations. So, and then we go on with 5. So both 3 and 4 are absent. We have 3.5 instead of them. And then we'll go on with the rank 5. And we see that after 28, do we have 29? We don't, as far as I see. But we have 30 also twice. As we have 30 twice, we do the same. We say that if they were different, their ranks would be 5 and 6. And so as they are equal, their ranks are between 5 and 6, 5.5. So then we are to go on with the rank 7. So as 5 and 6 are absent, so we see that then we have 31. 31 has rank 7. Then do we have 32? Yes, we have. So 32, 8. Then 33, 9. 34, we don't have 34, but we have 35 twice. So ranks are 10.5, as so they share the 10th and the 11th places. So rank is 10, 10.5. Then the next rank is 12. So 36. We don't have 36. We don't have 37. We have 38 twice. So their ranks are 12 and 13, and the average is 12.5. And then we have 39, rank 14, 42, rank 15, 44, rank 16, and 46, rank 17. Oh, no. I missed 43. So 43 has its rank 16. And so that means that here we have 17 and here we have 18. So this is the ranking. And now we are to find the W statistic, sum of rings of the elements of the second sample. So we are to add these numbers. So W is equal to 1 plus 12.5 plus 14 plus 3.5 plus 5.5 plus 2 plus 8 plus 10.5. So this is equal to 57.5. And now we are to standardize this W and to find its expected value and variance before doing this. So E of W is, according to the general formula, it is m over 2 times m plus n plus 1. M and n are sample sizes, so in our case m is 10, m is 10 and n is 8. So here we have n over 2, so 8 over 2 times m plus n plus 1, so 10 plus 8 plus 1. And this is equal to 76. Then the variance. Here we have m times n divided by 12 times m plus n plus 1. And this is equal to 126.67. If we round up to 2 digits after the decimal point. And so now the standardized W is 57.5 minus 76 divided by the square root of 126.67. And this is approximately equal to minus 1.69. So this is the observed value of the test statistic. Now we say that under an assumption that the null hypothesis is true, the test statistic is asymptotically distributed according to the standard normal distribution law. And this means that we can use the quantiles of the standard normal distribution for critical regions. So we say that as we have an alternative hypothesis of theta less than 0, then we have left-tailed test, left-tailed critical region. And here we have the quantile of the standard normal distribution of the level alpha. Alpha is also not given as in previous problem, but let's take the default value also, 0.05. And so we are to find the quantile of the level 0.05 in the table. And so it is equal to quantile of the level 0.05 is equal to minus 1.65. Quantiles of the standard normal distribution are symmetrical with respect to 0. So quantile of the level 0.05 is minus 1.65. Quantile of the level 0.95 is plus 1.65, and so on. So the border between the critical region and the acceptance region is equal to minus 1.65, and here we got minus 1.69. So we are in critical region. We are somewhere here. Our W tilde is equal to minus 1. Let me write this. Not here, but here, minus 1.69. This is the value of W tilde. And so what does it mean? It means that as the observed value of the test statistic falls into the critical region, then we reject the null hypothesis in favor of the alternative one. So HO is rejected in favor of HA, in favor of the alternative hypothesis. And so that means that so now let's answer the question we were asked. So they say, can we say that the B is better? And so the alternative hypothesis means that B is better. Alternative hypothesis means that average time visitors spend looking for their flight is less for the B variant, and this means that B is better. And so our answer is yes, we can. Or better to say yes, we can at 0.05 significance level. One more thing I should say here, that so what does it mean when we have our test statistic very close to the border between critical and acceptance region? So we see that only the difference is only 0.04. So the test statistic fell very close to the border with the acceptance region. It means that actually, so we can make a decision. We can say which one of the two hypotheses is rejected and which one is accepted. But the level of so we are not so very sure. This means that it's better to consider a greater number of observations. So if you see that the value of the test statistic is close to the border of the critical and acceptance regions, this means that you should you should take more observations to make the situation more clear than what we have here. So, and also we can find the p-value. We haven't found the p-value for the previous example. Let's do this here, as we have very simple formula. So for left-tailed tests, p-value is just equal to phi of the test statistic. So phi of minus 1.69, and this is equal approximately to 0.0455. 0.0455. So this is the p-value, and we see how we can use it as an answer. So we were asked, can we say that B is better? How we can answer this question using the p-value? We choose the significance level. So if we prefer p-values as an answer, after we have got the p-value, we choose the significance level and we say our significance level is 0.05. Our significance level is greater than p-value, the p-value. That is why the null hypothesis is rejected in favor of the alternative one. So if the p-value were less than our significance level, if our significance level, if it were less than the p-value, then we would say that we accept the null hypothesis. We fail to reject, so we accept the null hypothesis, and that's it. So after we have got the p-value, we are to choose the significance level and to compare the significance level with the p-value. If our significance level is more than the p-value, then the null hypothesis is rejected. If our significance level is less than the p-value, the null hypothesis is accepted.